Hey, we're here. I am. I just have a quick question on homework 8. Yeah, let's do it. Kelsey, what is your question on homework 8? Just getting started here. Let me load up homework 8 in the background. There's all the things for whatchamacallit, the methods inside of Caret. So I think this is 320 though. Homework 8 for 320, I'm guessing. So I'm going to log in here, go to homework 8 for 320. It looks like I'm going to see. I think the graders should get caught up. Lots of grading. Lots of grading. Lots and lots and lots and lots and lots of grading. But let's see. Oh, 474, 474. Sorry, Kelsey. 474. Let's take a look at homework 8 for 474. You got it. I know 320 has like an upcoming in 474. 474's homework 8 is going to be vanilla regression. Wow, great job. Vanilla and regularized regression. So here we are. Let's open it up. It says 9 on it. Sorry for all the files, different names. Let's see. Which one are you looking at? Homework 7 is due next. Yes. Yep. We have one due tomorrow. Yep. Dennis is right. And so we should have for 474. Here, I think I showed that right there. Sorry for like if the numbers are a little bit different. Here's the 474 schedule. You can see here we have concepts in predictive analytics. Oh no, don't do anything. We have vanilla and regularized logistic right here. We have tree-based models and support vector machine. So you can see we have this due tomorrow night. Got to see what day it is. So this is due on Wednesday, Friday, and then this should be Saturday, Sunday, and then Monday, Tuesday, and then this will be, I think that'll be a bonus. So support vector machine will be a bonus. I'll make this a bonus assignment. You know what? Let's just do this right now. Let's just go here. And let's say bonus assignment. There we go. Let's make that change right here. There we go. And I think that'll work really well. Let me look at the date on this. Try to give everyone as much time as we can because there's a lot. That's the 30th. I like that. Because then the take home. So there will be a bonus assignment. Sorry for any confusion on the numbers. Let's see what the questions are. So how many are dropped? There'll be 3 dropped now. Since I have now made a bonus, there'll be 3 dropped. Let me change that. Well, I don't want to change it yet because I don't want people to overly estimate their grade. What happens at the end a lot of times is every time I click on the RMD in Canvas, it opens it up in a dot. Ben, go to File Save As. So you want to go to File Save As and then delete the .txt. Some web browsers do that. Ben. So, or like go in and edit the file name to just be .rmd by going like rename file and delete the .txt. Your web browser is trying to help you out because it doesn't recognize the file extension. It's like, oh, I'll change this right here. Oh, good. Yeah, that's what I thought. I was like, are you on the next one? I was like, wow, great job. Let me go over to that one right there. And which one are you looking at on that? Let's see here. This is Concepts in Predictive Analytics. Come on, Canvas. You can do it. Here we go. And let's get it downloaded here. We've got the file. And we'll need to load up so that should load up. Good. We need to install Segmented. There we go. Those should be installing. There we go. We're installing Segmented. And now we're going to load up the environment, which there's probably a load, but I probably don't have the right. There's the load environment on it. My guess is I'm not in my working directory. Am I? Error in read, so we're not in the right working directory. Session, choose working directory. I am in downloads. What is going on? Oh, it's just an error. Do we have the right things in here? I don't want to erase everything. We'll see what happens. We'll see what happens as we go through the assignment right here. We will see what happens. Question 4, but just the last 3 on that question. Hey, what's up, Jordan? And I think we are caught up on everyone's questions. This is the next homework assignment that's due. Sorry, it says homework 8 on it. I should change that. We skipped an assignment. There was another function assignment that we skipped. So if you're wondering how things got a little bit out of order, there was 2 assignments that we usually do on functions, but I skipped one because I don't want to overload everybody. And I was like, we'll skip the one on functions. We'll skip like the second assignment on functions. So if you're wondering how things got slightly off in the numbering, and then because I decided to release them all, I didn't notice the change. I need to go back in and change that. So more changes, but it won't affect anything. What's listed as the due dates is listed, and sorry for any confusion on the numbers. Is it, can you read off me the part of the question? Question 4 right here. The numbers. This is what happens when we update stuff. What does it say, Kelsey? What is it? Question 4. Just the last 3 on that question. Are you talking about responses right here, interpretations? Are you talking about these 3 right here? I could use some help on, you bet. I think Jordan, it's 320, right? I think Jordan, pretty sure. All of a sudden, again, the class is confused. Are you talking about these 3 right here, Kelsey? Because actually, this will help with 320. This is a good review of 320. If so, we'll see what Kelsey says. What's up, Carly? Oh, which one is it, Kelsey? Am I going mad? Where is it? We have a jump. Where is it, Kelsey? It's learning how to specify your model, necessary skill for linear regression models and match. Okay, yeah, cool, awesome. So let's just do that. Okay, cool, got it. Is there really 2 question 4s? Okay, learning how to specify the model you want to fit is a necessary skill. We have here x1 through x50, and the variable we want to predict is y. So you see here the formula format. This formula format is clear. I'm just going to drop it in chat right here. And thank you, Kelsey, for pasting that right there so we can see exactly which one we're working on. So 100 points there, Kelsey. And so you see we have this formula format right here, which is going to be y is explained by x1. And then, so the first one we have, people should know this one pretty instantaneously. I thought I had my coffee over here. What is going to be y explained by all the x's, all 50 x's? All 50 x's. What is y explained by all 50 x's? That one's pretty easy. We should know that one, like, and this is good for 320 should know it too. 100 points first person. You get up to 200 points during these off-star spawn points. Y tilde dot, boom. That one we know, like, instantaneous. Now, if you want to do y to all the interactions, so this one's y tilde dot. And then if you want to do y to all the interactions, how do you do all the second order interactions, the 2-way interactions, which is something we'll be talking about in 320 tomorrow. So how do you do, yep, that's it, just dot raise second. And so we'll just keep expanding the window, not that window, this window here. The all 50 predictors except these right here. So this is where we have to do the minus right here. We've got to do dot minus x2 minus x27. And you can kind of, one thing you can do, I'll show you what to check this out. If you want to do just these ones right here, you go here and then you go x12 plus x42 plus x46. This one confuses people right here because now if we want to do their 2-way interactions, what you want to do is you want to take these right here. We'll expand the window again. And you take these right here and you have to raise these. This is one people usually get wrong right here, is you have to raise this to the second power. Watch out. It's kind of like the dot right here has everything. So when you raise the dot to the second power, you don't want to multiply everything together though. If you do this, you'll create 3-way interactions. So doing this right here would create a 3-way interaction, which would create the 2-way interactions and the single order terms. So this is kind of a review of 320 right here. Why 320 is a prereq is that if you do blank times blank times blank, you get the 3-way interaction, the 2-way interactions, and the single order terms. Does that make sense? This is not correct right here, the way this is written, because this will do the 3-way interaction. It's probably just going to be easier if I make it look like this. That's not the answer anymore, but this. So this creates the 3-way interaction between x1, x2, x3, the 2-way interactions between x1, x2, x1, x3, x2, x3, and the single order terms. And we can really exemplify this here with some practice. Like what we're going to do here is we're going to insert a chunk and we're going to create a fake data frame. So we're going to create a data frame where we have data.frame. And it's important to like think about how can we show this. Y is going to be random normal numbers. So this is random normal. And we're going to do 100 random normal numbers. And then we're going to do x1, x2, and x3. So there we go, x1. I know it's not x1 yet, 2, and 3. So now this is x1, x2, and x3. So if you look at what I've created here, and you don't have to do this part, I'm just showing what it'll do, is we've created a data frame with the following variables. Does that make sense? That we now have a y, x1, x2, x3. So what we can do is we can just make a simple linear model right here, or just use our classic techniques of going linear model y tilde x, and then x1 plus x2 plus x3, comma data equals, and here, let me drop this in the chat. If you want to try making models, use that right there, because now we can see what happens when we do the following. Didn't do a capital DF. And we can go summary of the model, and we can see the coefficients in the model. So if you notice right here, we get the coefficients x1, x2, x3. But here's where the changes start to occur. If you were to do this right here, you get the three-way interaction of x1, x2, x3. So remember, this code right here with multiplying them all does not get you the two-way interactions, it gets you all three-way interactions. If we want only the two-way interactions, we go here and we add them, and then on the outside of it, we raise it. But this code right here that gives you all the two-way interactions, you can see right here, two-way interaction, two-way interaction, two-way interaction. This code right here, and pay attention 320, because this is tomorrow. This is your guys' lecture tomorrow. This code right here is the same thing as doing dot raised to second, because I only have the three variables. So the dot raised to second does the same thing. It's kind of like everything right here is inside of the dot. And once again, we see other ways. If you want to not include x3, you could write the code dot minus x3, and now it'll have everything but x3. Is this making a little bit more sense right here, how to handle this and how the dot means everything? You can take a bunch of variables, square them, and you'll get the two interactions. If you multiply variables, you'll get an interaction between them. So if I wanted x1 and x2 and their interaction, I could go x1 plus x or times x2, and that'll give me the interaction between them right here. Yeah, it's you just have to know what the difference between the dot means everything. Squaring things makes them interact with each other, and if you square together a bunch of stuff, you'll get more interactions. Like if you were to do a four-way interaction, it'll do all, like we'll just add in, whoops, wrong thing. So now we're going to add in 5 variables here. So this is a 5-variable data frame. You can see right there. And you could do this right here. And now you've made the model with all up to 5-way interactions. Now, this is a bit ridiculous. This is an overfit model. 474 should know this, that this model is probably very, very overfit. And look right here. You even see this from today. We talked about the R-squared adjusted. Your R-squared is 28% of the variation in Y is explained by the variation in X. But remember, the R-squared adjusted is a much fairer way to assess it. Also, these are random numbers, and we usually miss by about 1. These numbers are generated randomly, and we're usually missing by 1, and the numbers generate anywhere from 0 to 1, I believe. Like random normal numbers, oh, it's a z-score. So we're usually off by, that is so interesting. The RMSE is 1, and the RMSE is in terms of standard errors, which is basically a z-score. So I'm not shocked that the RMSE for random data is basically 1, because it was z-scores we were trying to predict. And it's I don't know. I'm amusing myself. But is it making a little more sense? I know Kelsey asked about this, and we'll look at the last few here. Well, I think that does it. Did we just do them all? Or we got 2 more down here? Come on, R. Don't be crazy, R. All predicting variables except these, and including two-way interactions between x2 and between x3. Okay, so let's start with the first part. If we want to include all the variables, what are we going to write first? This is the last tricky one. If you want to include all variables, what are you going to write first? Including all variables, what would you write first? Dot. There you go. Then you want to remove those variables. What are you going to add to it after that? What are you going to remove to it? You're going to do tilde dot. Yep. And then what are you going to put to remove the variables? All you guys figure it out in the chat as we talk. You're going to minus them off. Yep. So then we'll minus x33 and minus x49. And then how would you add in two-way interactions between x2 and x3 and x4 and x5? How would you add in, I don't have any of those up there anymore. How would you, like, show me how to do the two-way interaction between x2 and x3? Because then you'll have to add those on. Because then you'll do, like, every variable, subtract this off, add this on, add this on. So if you can hear it. Carly, that might work. That might work. Let me try that. That's one of those things that the grader might take off points on, but then I'll be like, it works. So we can test out Carly's format right here by going and just dropping it in here and seeing if we get it. So to see if this gives us the two-way interaction, and I think it will. And you see it does. So Carly, like, this is where always look over where you lose points or anything, because that is correct. I would just, as we see other people put in the chat, you can just do this right here. And we can check this also, and this does give the two-way interaction. It also preserves what we call model hierarchy. Let me explain briefly what model hierarchy is, because we will be covering this tomorrow in 201 or 320. I don't know what classes we're in. Model hierarchy works the following way. When you do model hierarchy, there's two examples. We have here model hierarchy where we have x1 and x2, and then we have the interaction between x1 and x2. So as everyone see right here, we have x1, x2, and then the interaction. So if you're building this house, what would make this house topple? To remove what from this house? Tell me one of the things you could remove from this house that would make this house topple. And Vedrina, you're also right. 100 points. Kelsey, Vedrina, Jordan, Carly, Nitin, and Dennis. Everyone on screen right there, and Ahmed. So x1 or x2, yep. If you have x2, but you don't have these below it, then you don't have model hierarchy. So model hierarchy says, this is the notes for model hierarchy, which we'll talk about tomorrow also. Model hierarchy says that if you have an interaction, you must have everything that goes into that interaction. So if you have a three-way interaction, here's the really confusing part. If you have a three-way interaction like the following, x1 times x2 times x3, what single order terms would you need in there? If you have a three-way interaction between x1, x2, x3, what single order terms do you need in here? This is going to be a weird looking house in a moment. I usually don't draw the three-way interaction house. So if you have x1, x2, well, I'm giving it away. You need these. That's the answer. And then you would have here this one, and then you also have like, the other one just looks weird. x1, x2, x2, x3, x3, x1. So you have to have x1, x2, x1, x3, that's one's going to be in the middle, and then x2, x3. Sorry they're not on their respective places, but those are all two-way interactions, and then the top right here is x1, x2, x3, and that has preserved model hierarchy. Sorry, it's just the permutations of the lower order terms, so that these are all, to have model hierarchy preserved with the three-way interaction, you have to have the combinations of the two-way interactions. So does that logically make sense right there? Preserving model hierarchy says if you have a three-way interaction, you have all two-way interactions, and you have all the single order terms that go into it. This being, like, I can show you one that preserves model hierarchy. Let's look at a model that preserves model hierarchy. Would be this model right here will preserve model hierarchy. And let's take a look at it. Because if you notice, it has the single order terms. Well, let's go to the biggest term. The highest term in the model, x1, x2, x3, has every two order term, like the two interactions that go into it, and the single orders. We can destroy model hierarchy by doing the following. We're just going to go right outside this and go minus x1. And now when we print it, we will not have model hierarchy preserved because there's no x1. So this is an example of model hierarchy not being preserved when it comes to interactions because there is no x1 term. If you have x1, x2, if you have the x1, x2, x3 term, which is a three-way interaction, complicated thing right there, then you have to have all second order terms that go into it and all single order terms. Yeah, it's a big thing. Yeah, all these things overlap in disciplines. Great job, Jordan. 100 points right there. Yeah, I'm sure Charlie talks about it. Preserving model hierarchy. If you have interactions, you have to have what he probably called the main effects. Was he calling them main effects? If you have an interaction between two things, you need what he would call the main effect. That's what we call it in process control. So SPC, statistical process control. Nice job, Jordan. Yep, main effects. So it's literally over. You learn one of things. It's like a big thing. It's like, oh, if you have an interaction, you need the main effects. Yep, that's what we do. That's what we do. I love it. Great job, Jordan. That's BAS 340. Yep, you got it. And so good practice right there. So one of the things, if you learn these things in our classes, there's so much overlap. And one thing I want to say is, like, jump is really good, but you can use R for 340. I mean, I don't know. Charlie's going for, I don't know. I love R. He's going to be like, no, R take over. I love R. And then Python people are like, Python's better. And I'm like, no, R's better. It's just, I don't know. Everyone's got their preferences. I like jump a lot. I've got jump on here, obviously. Where's jump? Here's jump down here. So I think that does it for this one. And then let's mention one last thing about model hierarchy, and then we'll understand it completely for tomorrow, so we'll be all prepped. The last thing for model hierarchy is if you have a squared term. If you were to have x squared in your model, like x1 squared, what do you think should go in your model? What do you think needs to be in your model if you have a coefficient for x1 squared? To preserve model hierarchy, which you don't have to do, it's kind of a good idea. It's like one of those things where like, that's a good idea. What would go in your model for 100 points? What should be in your model? Just kind of look at the way that house is built. Yep, X1, Carly, 100 points right there. This is a model that has model hierarchy. This is a model that does not have model hierarchy. But you could also have like X1 to the third power. And if you have X1 to the third power, what 2 things would you need in your model? To preserve model hierarchy, what 2 things would you need in your model? Pretty easy, quick and easy questions. Once you understand model hierarchy, especially if you kind of view it this way, like a house being built. So my 2 favorite examples are just like the interaction between 2 variables, that if you have X1, X2, you need, and that's an interaction between them, you need X1, X2. If you have, yep, you got it, Vedrina and Carly, 100 points, 200 points are in these office hours. And we were talking about the answers to the last, yeah, I think, did people kind of get first power, single order term? Yep, you can leave that in the chat and we'll be nice. We'll leave that in the chat. Don't worry about jumping out the message. That should be right there. And you could just multiply them. Either way, there's many ways to write it. Please tell me if you think the grader counted off. I think the grader's really great. She's doing a good job. But sometimes the graders, there's so many variations on how to answer these things. Please tell me if you think you got the points and you think the grader took off points. There's multiple ways. Like, I think it was someone said an answer earlier and I was like, I think that'll work. Like, I looked at it and I was like, that looks like it'll work. And then I tried and I was like, yeah, it worked. This is not the way I would write it, which is fine. Just if it works, it works. So what other questions? I think Jordan might have had one. Computer, you behave. And so what? I think Jordan had one earlier about 320. Yep, 2C and 2D. Jordan, you're 320, right? Sorry, it's like, see, it helps so much when I can see students. When I can't see students, I'm like, I think I know. There's a lot of names I know. And then, oh, Nin, we were talking about something earlier. 474. Why am I thinking people are 320? Wait, do we have any 320s in here? Dennis is 320, right? Dennis is 320. Dennis looks, I like it when people come into 474 and they hang out. So, yep. And Brad's here. What's up, Brad? Yep, Brad is here. Shop into the Discord. Is Discord up and going? I feel like I should. I don't know. Only one person's Discord. What's up? Okay, let's do the 2C and 2D. Feel free to ask anything you guys want. Let's do it right here. For this problem, we'll revisit how we fit models in BAS 320. What? Recall the syntax for predicting variables y, all the variables dot. Adapt the syntax so that the dot is used as the formula and the 3 appropriate columns of train are used for the data argument. Verify the summary of the model below. Figure out and explain why all the values in X15 of summary only has NAs. Got it. Okay. I think I showed this in 320. Did I show it in 474? I don't think I showed it in 474. 1,000 points. Does anyone know why something would have NA? It actually deals with multiple regression, and it has to do what variables are bringing to the model. It can be partly in reason for that. Actually, I think this one's a little bit different. Well, it kind of is that reason. That's why things will get NA. And so this confused me for a long time. What model are we building? We're building this right here. Are we building it on all of them? I think we're building it on the limited data sets. Let me make sure I have the data loaded up, and let's see what we got. Did I load it? It's the pro launch data set. Run summary on pro launch, prod launch. Prod launch not found. Is that thing loading? Let me load the environment. So it does load. Okay. And then let me load prod launch. Good. We got prod launch. And using the random, split the data into 50%. Sure. We might be all right if we didn't do that. It was 2C and 2D. Well, let's split the data into holdout and train. That's a good practice to do. Using the random seed 474. Tell me if I miss anything. Split the data into 50-50. So what we want to do is we want to make a train rows right here. So this is one way to store it. And why are we appending this right here? Can anyone tell me just theoretically why am I appending this right here? Because what am I about to do on this next line of code connected to this? Which is it's kind of a good idea to append this because there's a reason, and I'll start writing this code right here. That's the reason. Who can explain that? That's the reason it's appended, though. Like, the reason I'm purposely appending these codes is because of just what I wrote right there. And now we want to sample 1 through the number of rows. Well, yeah, we're going to prod launch, and we're sampling 50% of the rows of rows prod launch. Like something, I blinked and something happened. Oh, that's what happened. It went to a new line. I was like, where did it go? Yeah, so the reason we're appending this right here is this is the same thing as me doing this. That's the same thing as me hitting enter twice of me doing this. But what I want to ensure is that when somebody runs this line of code, they immediately run the sample function, because the sample function uses a randomness procedure. So I want to make sure that when somebody runs their code, this line runs in tandem with the other line, and they can't possibly split it up somehow. So yeah, Ahmed, good right there, 100 points. Yep. So we're storing into train rows, but then it's running it as one line of code. So I'm like, okay, when you run this, both those things are going to run, because it's two separate lines of code appended together to run as one line of code. And that's the reason. It's like, well, why do we do that? So that automatically it happens. Now we've got here the train, and the train is going to be, we're going to go to prod launch. And on prod launch, we're going to go and we're going to take train rows. Now here's something people forget a lot of times. You need this comma because it's two-dimensional. And then we're going to take this, we're going to copy twice, and we're going to go to this, and we're going to go to holdout. And here's something I forget, is I forget to put this minus right here, because we're going to take the train rows for the train, we're going to take the not train rows for the holdout. We can do it again. That's fine. Just overwrite the train with what we already have. We've got some confirmation checks right here. Oh, let's hope it works. I'm a little scared. Because sometimes it doesn't work. Verify the summaries of the profit. So let's go here to summary. And I'm going to see something right here, and hopefully I don't have to send an announcement about it. Train, $profit. Did it work? It worked. Don't worry, it's just a decimal thing. And options, digits, equals 3, 6, 20. The digits is so weird in R, because the way it works, sure, that worked finally. I still do not understand why digits is not just like how many digits after the decimal, and the output there is set to the default. We can also confirm the holdout by going here and going to holdout and confirming we have the right holdout. So we have done this properly. If you are getting a difference, please tell me. It's probably due to your RNG kind, just so we confirm. Let's do this RNG kind. Not RND kind. RNG kind. It's sample kind. This took me semesters to learn. Rejection. Let's try this. See what we get. The answer is we do not get it. Okay, so it's not rejection, it's rounding. So if you notice, I am not getting the sanity checks, so don't do that. Your RNG kind should be rounding. And now we get it, and we get the sanity checks. So just so you can see, this line of code, you might need to put that at your chunk if you're not getting your sanity checks. Very sorry, it's just the way R does the random number generation. And if you don't have the right type of random number generation, you won't get the right random numbers. That's something we figured out over time, because most people don't look that in depth to how is R generating its random numbers. That just kind of says, we talk about it like, are you playing on PC or Xbox? It's like the Xbox people get these numbers and the PC people get these numbers. So that just controls the randomness. And I'm going to put it at the start of that chunk just so I know it's going to generate the numbers that way. Not needed. If you get the numbers, you're fine. Okay, so we get into the meat of the question that Jordan was asking. For this problem, we'll revisit how to do this right here. Adapt the syntax with the twiddle dot. Q2A1, you bet, Brad, you got it. We're going to do the 2 questions here, then we'll hop over to 320, you bet. Adapt this syntax with the twiddle dot is used as a formula, and 3 appropriate columns of train are used for that. Okay, so we want to use the 3 columns of the train data. And which 3 columns do we want? Adapt the syntax so that the twiddle dot is used as a formula, and the 3 appropriate columns of train are used for the data argument. And I think the 3 appropriate columns were given here at the start. It's the 3 appropriate columns are going to be this right here. I think, are we looking for 1, 5, and 16? Yes. Okay, I think it's this right here. I think these are the ones we want. So I think it gives it to us. If not, because we're just going to take this and we're just going to go to train, and that gives the data frame. So when you do your function, this is what confuses people. When you do LM, we're predicting profit with a lowercase p, I believe. Twiddle dot. The dot means everything, but your data frame does not need to have every variable in it. Now, the reason we need one is, why do we need one? Someone's got to explain to me in words. Oh my gosh. Someone, while we're doing this here, someone's got to explain to me in words, why do we need one? Why do we need one? What does one represent there, and why do we need it? What does one represent, and why do we need it? Like, why? And you have to look at, here's a hint, just to separate out what we're looking at. You've got this space, and you've got this space. First column is profit, yep, so it's the Y. And so you have to, and it does have a capital P, good thing we looked. And it reads through spaces, unexpected symbol, twiddle dot, comma. There we go. So I didn't put my comma. It's Y tilde dot, comma, data equals, and then you could just put train, but that would do everything. So we have now made our model, and it's saying, oh, you can also see the answer to the other one. It's saying that we will get NAs. 320. What do you notice about the variable x15 and why we're getting NAs with it? 474s, we have a name for this too. We have a name for this in 474, and 320 should know it by another way. So it kind of all combines what we're learning. I love this question. It's a really good question for 320 and 474. 320, this brings what to the model? Look at the variable right here, this column. And 474, it has not near this, but it has 0 this. So x15, 320 should tell me a key term that it does not bring with it what? Let's see if 474 or 320 can tell me about this variable. It does not bring with it, hey, what's up, Andrew? 320 should say that variable brings with it what? And 474 should say it doesn't have near 0 this, it actually has 0 this. Who knows 320 or 474? How is something significant in a multiple regression? It brings with it what? 100 points. Who knows these answers? Well, and so it doesn't look random. Did you say random? I don't use my rainbow anymore. 0 variance. Yeah, this has 0 variance. So the variance here is 0. So the variance here is 0 variance. So it has no, remember, the variation in x explains the variation in y, or the variation in y is explained by the variation in x. So this has no variation to it. And in 320, we would say it brings with it no additional new information. But because of the no variation in it, it has no variation. It has no ability to explain, and we're not able to make estimates for it. So it's this one. So we're not, you see now the decimals look all crazy. But it's not able to create estimates due to it having 0 variance. And so it's just junk. I mean, sorry, X15, you're junk. You got here 0 variance. It's not number of yachts, because apparently people own yachts. So 474 gets that. The result matrix produced below is a set up so that you record the RMSE on the holdout sample for all the models that contains at most 2 predictors. The value in the row labels da-da-da-da, and the RMSE on the holdout, and the values in the da-da-da-da, using a nested for loop. Ooh, fun times. Oh, you guys chose a fun one for me to do. You're like, do the for loop one. Okay, let's do it. And then we'll do Brad's questions here. So use a nested for loop. And so the whole point of it is for you to code this first. The point of this is to make this right here. I need someone to tell me what this is. What is that? Well, Brian goes and gets coffee, so he should be like, I wish I had a coffee break screen. So Brian's going to go and get coffee. Tell me what that is, because we just made something we need for the for loop. Boop. Be right back.
I'm in business law. What's up, Andrew? What questions did you have about business law? I know all the answers to business law. I got my Apple glass. Everything sound all right? I don't know. Just having fun, guys.
It's like when I do that voice, I also talk like
This when I'm talking, even though it's already doing it for me.
Okay, let's get serious here. It's the skeleton. You know what's going on. So there's a lot of ways to do this, but what you probably want to do is you want to get the RMSE out of this. I think you can get the RMSE this way. Will that do it? No, that's not got the RMSE. How do we do it? Summary creates. There's a quick way. Here, let's do this. Let's store summary into M. And then let's look into M here. There we go. Coefficients. Coefficients doesn't have it. Coefficients has that. Do we have to compute the RMSE? Man, I don't want to compute the RMSE. I swear there's a way to get the RMSE out of this. I might look it up. There's the R squared adjusted. There's the R squared. There's the sigma. There's the F statistic. There's the alias. There's the coefficients or the residuals. I can compute the RMSE. All we have to do is just, I can probably compute the, well, okay. To compute the RMSE, do the following. Actually, we need to compute the RMSE because we're doing the RMSE in the holdout. Okay, so I stand corrected. This is part of the skeleton. To compute the RMSE, what does the RMSE stand for? The RMSE, we have to know what the RMSE stands for, and I stand corrected. I am going to have to compute it because we're not looking for the RMSE on the training. We're looking for the RMSE on the holdout. So we're going to make a model from the train, and then we're going to test it on all the holdouts, which theoretically is not what we do, but this is just to show you different RMSEs on the holdout because we're going to let the validation pick it if you know how predictive modeling works. But so it's kind of just having you practice and see how we could look at different RMSEs and see which model works the best on new data. What does the RMSE stand for? I can't remember these things. Probably turned out all right today. No one knows what the RMSE stands for? Oh no. If no one knows, I don't know. I'll never figure it out. And I'll just vanish. Are my buttons not working? Buttons be weird today. Root mean squared error. You're right. Root mean square error. We know what root mean square error is. So let's go to square root. And then we need mean. And then we need error here. So I'm going to write it like this for the time being. But the error right here, we need something. We need the actual minus predicted. So nice job in the chat. Actual minus predicted. So the error is going to be the actual minus the predicted. So we need to find the actual. And the actual is simply going to be the holdout $profit. Does that make sense that that's the actual value? So that's the actual value of what something has. Does that make sense? That's the actual. And I forgot one thing right here. Root mean squared error. So that's the actual value of it. Like this is the actual profit. Can everyone agree with that? That's the actual. This is the actual profit. Now we need the predicted. Luckily, I wrote it as predict because I was already thinking about the thing I was going to write. And we're going to go here to predict. And we're going to predict using our model M on new data equals holdout. So this will make predictions on the model using the new data. What is it not like? It says no applicable method for predict applied to predict LM new data equals holdout. What happened? Let me see. Maybe I made a thing with mine. Wait. There it goes. Prediction from a rank deficient. Oh, because of the zeros. That's because of the zeros. It's rank deficient. This is on Canvas. Yep. We put a lot of hints on there. Like, check this out. Predict, holdout. And I believe that is everything I have written right here. So you can call it predicted holdout. I just call it error right here. And then I'm doing the work in two. Does it make sense, Jordan, here? What I'm doing with the two steps is I'm storing this as an error, and then I'm taking the root mean square of it. So I'm kind of just taking and doing, and this should get you the same thing. Does that make sense, Jordan? With what we have right here. And then this right here. So let's make sure it works. And then we get that right there. So we found our error, which is the actual minus predicted. What is this again for 100 points? Actual minus predicted is just what the model makes. Starts with an R. I Key terms we should know: how much the model misses by is its error, but this is more often considered in the R or the re something. So we should like know these key. You got it right there, Dennis. 100 points. You know that's a residual. That's just actual minus predicted. It's just how far off the model is. Andrew, 100 points also. And all we're doing is doing the root mean squared error of it. So if you look, root mean squared error. So we got that going on. We could also do the sums of the squared error. So I mean, like, you could literally find your sums of squared error. So here's the, yeah, just do this. Here's your sums of squared error on the, there you go. There's the sum of the squared error. So that's the SSE on the holdout. So that's holdout. No, what have I done? Okay. So now we're going to go here. And this is where it gets interesting. We've almost created our skeleton. And don't do this under 2C because it's not where you do it on 2C. I'm just creating a skeleton for the time being. What we need to do is we need to create a matrix of values. It probably says that on here. You'll need to just say, there's the matrix. Okay, cool. And then there's a check. Okay. So the matrix of values right here literally has your results. And if you look, we just have a bunch of zeros in here right now. We're going to populate this matrix. If I were to take this code right here, where do you suggest I put this code in the matrix? We are going to run to one. We'll do it. Yeah, there's something else we're going to have to code in a moment. Where would this code go in the matrix? Where would this code store into in results? Because we need to store into results. And where is this code going to store into in results? This is the key to this one. Brad, we got your question next. Where's this code going to store into? It's 2-space. Where will that code store into? Look on line 99 for a hint. Where will that code store into? Line 99 is the hint. Because we're going to start populating that matrix with all the combinations. Close, Andrew. Close, close, close. 1 is the y variable. 1 is the y variable in the matrix 2-space. So we're populating the matrix. One of these days, computer. We're populating this matrix with all the combinations of the x's such that I don't want to give away the answer. Just remember, we're populating the matrix with all the combinations of x's. And so look at, I can't see it anymore. Look at Andrew's thing for a hint. Remember, 1 is the, so we're doing all the combinations of the x variables we could do. And then we have one more thing to do to this. So where do we want to store it? Where do we want to store this combo in? What position in this matrix? There's 2 answers to the question. Remember, it's 2-space, though. Remember, it's 2-space. Remember, it's 2-space. It's 2-dimensional. This is a does everyone see this is a 2-dimensional object? 2-dimensional object. Since it's a 2-dimensional object, what row column will we store it in? Well, one is profit, though. 1 is profit. One would be profit. And actually, let me think. Okay. Actually, because, yeah, let me see one thing. Because actually, let me look at the train real quick. There is x1 through x20. And the 5th column is x4. Okay. So it's trickier than I thought. So we want to store this into, because you're basically right with 516. But it needs to be 4, and then it needs to be 4 and 15. 4 and 15. You might be wondering, why is it 4 and 15? I'll show you why right here. Because the model we've created, because y is in the first column, we're using x4 and x15. Does that make sense? We're using x4 and x15. So this is the position of the x's we're using. Now let's see if this works right here. And let's look at our results now. And what do we see? We see in position 415, we stored the result. Does that make sense? That in position 415, row 4, column 15, we've stored in the value of the RMSE in the matrix for that spot. Does that make perfect sense where I've just, my line 101 right there is storing into position row 15, row 4, column 15, because, and you say, why is it 415? Because this is X4 in the model and X15. But wait, doesn't this say 5 and 6? Yes, because the first column in the data frame is the Y variable, so everything is offset by 1. Because this is column 5, even though it's X1. Does the X4, excuse me. Does that all make sense right there? It's a lot to take in. Why are we typing in 5? Well, because it's X4. Why is it X4? Because the first column is profit, so everything, all the X's are just one different. And then why are we storing into 415? Well, because it's the combination of variables we have in the model. We have 4 and 15, and the matrix right here looks the following, and we do this. So that's exactly what's going on right here. Okay, we can fix this though. Watch this. 5 minus 1. And no, I'm deleting it. 16. Wait. Because it was, there we go. My brain is just not working today. Because I want to enter in. It should be this. It should be 4. There we go. That's got it. Don't touch my shoulder. Sneezed in it. Okay. And this is the first time I've actually... You could turn down the light on your left side. Is it this side? The light is not responsive today. Oh! I will work on that, Andrew. Ah! You guys are too crazy. You guys are just crazy. 15 plus 1. Okay, so the way I'm coding this, never mess with your settings while you're live. Never do that. Never. Bad idea. Bad idea. Okay, so why did I do this? Why did I change 5 to be 4 plus 1? Why did I change 16 to be 15 plus 1? The reason I did this is because when I reference 15 right here, I want to reference this. Does that make sense what I have going on right here? That when I reference 15, it's always going to be the same spot. So I can just say 15 and it'll do the right thing. And so we run into one last interesting scenario here. The interesting scenario is right here, right here, right here, right here. It's when we have what? I need you guys to help me out on this. I need help on this. The interesting scenarios is what? When the X's we pick are the what? The interesting scenario is with what? When the X's we pick are what? I'll start writing out the code, but start thinking about what I have highlighted right there, or what I've highlighted right here, and why that's an interesting scenario. When they're the same, Vedrina, great job. 100 points right there. Great job. So when the X's are the same, we run into a bit of an issue. And what we're going to do is we're going to write the code this way, because it'll get mad if we... Don't be weird today, computer. We're going to write the code this way. We're going to write... we're only going to pick one of them. So we're just going to erase this out of the code. And then let's just go here and just go 4. Okay, so this code right here will run the model and store to position 4-4. Does that make sense? So we go right here, and let's just see if it works. It should store to position 4-4. So if we check out our matrix of values, we should see in position 4-4 we found the value. And is that? It's the same, so I'm a little worried. Did this make a different root mean squared error? Error predict model M? Did this model create? It did create. I might have an error in my code, which I'm... Or they turned out to be the same. Oh, I know why. That is correct. Because the coefficients for the 15th was aliased. So just so I can see different numbers, I'm going to do the following. If you remember from it, the coefficients were aliased. So because of that, that's why the results turned out that way, because the 15th just didn't bring any new information. So now we see this number is different. I'm just testing the code to see if it works. When it turned out the same value, I was wondering what was going on. It's because X15 has in it no variation, so it didn't bring with it new information, 320 information right there, or 320 lingo. And we have two things of code right here to find if we have two variables and we find if we have one. So we need to do the following. We need to take all of this and put it inside of a for loop. This one's big, so good question for asking help with this one. We need to go here and go for, lowercase 4, where's my 4? There we go. And we're going to take all this code right here and drop it inside the for loop. So we go drop inside for loop. We're going to re-indent the lines, just helps us to look at it. There we go right there. And we need to go for I, for j, for 1 through 20. And this is where this really helped to classify these as these, because now I can call this I, and I can call this j, and I can call this I. This one doesn't matter if it's I. We only need to fix up one thing right here. We need to take and go if, should be good on this, if right here, and we have to put in our condition, if I does not equal to j, then run the following code. Does everyone see how I put inside of code brackets, if I is not equal to j, run the following code? Else, open this up right here, and this should work if I put it through this, run this code. So we can add a space right there, make it a little nicer, and then take that off the end of it. So if you look at the way this is structured, if I is not equal to j, it'll run this code. If I else, it'll run the code below it. Does that make sense what I did? I did that all kind of quickly right here because I made my for loop to go through the values of 1 through 20. It's going to go through all these. And so I and j will just permeate through these numbers. And if I and j are equal, it'll run this code right here. If I and j are not equal, it'll run this code right here. Does that make sense? I don't think anything changed in it. Does that make sense what I just did? I think it'll work. I think. I could be wrong. Could break. Only one way to find out. 50 warnings. Well, let's see. Did we get the sanity check? Dun, dun, dun. Looks like no. Maybe. No, we didn't get it. Did I, when I clicked, did I get a misclick? Okay, let's see. What happened? There are 50 or more warnings. Oh, haha. Someone corrected me. 100 points. I see it. Didn't change the rest of my code. What should be the error? And the error is pretty... yeah, the 3s is a problem. The 3s is a problem. And then there's another thing that's a problem. There's another problem here too. Because it's not permutating through the results and storing the matrix. And the 50 or more warnings are probably due to the aliased coefficients. Because it's some of the variables can't be used, so it's aliased coefficients. So it's probably giving warnings. And warnings are okay. It's just like, hey, did you know this? What's the other error in the code right now? What is the other error? Someone's got to tell me. Yep. And it shouldn't be JJ. This one, good job right there. It should be JIJ because it's going to take whatever the I was, and that's the variable used there, and whatever the J is, the variable there, and store in the I and J position. This is II because, and it could be JJ technically, but it's only taking one variable, and that's where we have like x1, x1, x2, x2, x3, x3, x4, x4. So it's only doing a one variable model. So this is all of our one variable models here, which is the diagonal. And then this is all of our two variable models, which have an I and a J position. And it'll go through and it should populate this. We take a sip of coffee. Should work. Yep, that's what we want to see. And did we get it? It looks like we got it. We'll cross our fingers. Did Sandy checks print out? I think Sandy checks printed side by side. Yep, 5. Ooh. Results look a little different. Wait, 5 zeros. Oh, you got it. 507630. There we go. It's same number there, same number there, same number there, same number there. And this right here is the same number here. So it looks like we got it. Wait, that's X11. Wait. Oh, there's another sanity check right here. Sanity check here, clears there. What is going on? Is this thing haunted? Let's just show the results here on this. And yeah, it's same results. Yeah. I blink and things change. The world changes. Oh, you're supposed to show your results, show the results. What do you run to get the populated matrix? This thing right here. Please don't try to write this out all in one go. Do it step by step. Please note the steps I did is that I tested it out and made sure it works. It's the hardest thing to learn how to code. My gosh, no, it's like, I'm looking at myself when I used to code and I'm like, no, because I'll even get mad at myself these days because I'll write something and I won't test it enough and then it'll break. And I'll be like, what did I do? Where did I make the error? So if you remember what I did is I wrote this code first and made sure it's stored. Then this shouldn't give output. You should go right here and run this right here. Great job. If you kept up with this question, this one's a big one. It's a really tough one. If you did it all, run this right here, and this should give you the output. Or you could just run the full matrix like this, and that'll print the full matrix to the screen. And you see it loops around the screen. And great job. It's really tough to learn how to code, and the more you practice, the better you get. And that's what we want. We just want our students to be good coders, good logic, good reason, good interpretations. I think it must be not changing the model. So I think I know it. If you're getting that for everything, look at this portion of the code right here. Do you still have the numbers in here? Do you still have the numbers hard-coded in? Because that was the original RMSE. So it sounds like you have the numbers not changing. Does that make sense? You might have to send it to me and I take a quick look. But it sounds like the numbers. Yep. Yeah. So, because if you get the same value, it's not changing the model. So there we go. Good job. Great. It's gotta be practice. I tell you, the hardest thing about coding is just getting stuck. And the best thing about coding is not getting stuck. It's like, yes, I fixed it. I got through it. I got through the coding. We talk about that feeling we get. I'm going to load up 320 right here. We talk about that feeling we get when we solve code and we're like, yes, it is solved. I wonder if our Brad and them on Discord. I love that we have the Discord. Wait. I'm about to start up the question. I have too much fun with that Discord. I think it's awesome. Check out the Discord, guys. We'll try to do more with the Discord. I think it's awesome. And we might even try to do some office hours via it. Multiple regression part 2. Send it to me, Jordan. I'll take a look. Send it to Jordan. I'll see if I can figure that out. Multiple regression part 2. Fall asleep is what we do. Load. Here we go. Brad said he was looking at. Brad wanted. Especially if you're 320, you're hanging out for some 474 stuff and you're practicing it. You'll get to 474, Q2A1, and you'll be like, whoa, I kind of know this stuff. I heard it. I practiced it. Q2A1. Investigation. Okay. Oh, cool. Yeah. Awesome. There's an extremely influential point, Q2 and Q. Oh, yeah. Okay, cool. We'll do Q2. There's an extremely influential point in the data set. Show the influential row, then explain what makes it unusual through the use of the scatterplot matrix. It's not possible to see why it's unusual with summary on the individual points. So we've got everything right here, and we're going to use the pairs matrix. So let's load up the bike data set, and I'm going to drop some cool code in the chat. I'm going to try to rewrite it. What am I doing? Reg class. Data ex4 bike. And there we go. Now, what we're going to do is we're going to run. Oh, does it want us to say which one it is? To print out the row. If I know the row off the top of my head, that'd be scary. I'll know it when I see it. I mean, we'll see it in the answer. So let's go to pairs right here. And you can just run pairs on the ex4 bike, and it should create. It's going to get mad right here. Cool. So we should be able to see the point. And the point is that point right there. The point is this extreme point, and you can see it there, you can see it there. It's got a very unusual combination, especially in its average temp effective. And it'd be pretty easy to make a model that kind of jumps out this point. We could, it's a little hard to tell. It's got a effective average temperature of about 12 and an average temperature of about 30. So what you could do to figure it out, sorry, I'm losing track over here. It's too small of a screen now. To find it, if you really want to find it, is you could go to linear model AVG temp explained by effective AVG temp data equals and then EX4 bike. And now we can look at an influence plot of M, and we will get the influence plot. Oh, wait, influence plot, not influences. Influence plot, and whoa, oh, it's not? No way, it has barely just not enough leverage. That's insanity. Well, let's do this. Let's fix that. That's ridiculous. That's one of my issues. Demand. There it is right there. 337. So it's 0.337. It's like a planet of influence. So it's got ridiculous influence, and now it has enough leverage. The previous plot, it just barely did not have enough leverage to have influence. Statisticians can talk about the issues with that plot. So you can print the row right now by going here and just talking about the row of data. You can see that this, as we said, has a very high average temperature. We'll go back to the plot right here that showed that. The average temperature was very high right here. This is an average temperature of about 30 for what we would see for the effective. And if we really want to zoom in on this plot, we could go here to plot, and we're just going to take the two variables right here. And I think we can use the formula format on this. There we go. So this is a better zoom in of what's going on this plot. We're getting this right here, and it's way off the thing. So you did it correctly, yep. And then I'm gonna drop one cool thing in the chat right here. I'm gonna try something that I like doing. Let's do PCH, or let's do col equals if else row names. Is that right? Row names of EX4 bike equals, and it's got to be in quotes, 337, and then we go here red, and we go here black. Will that work? Yes. Wow. It was, the students who showed me this were graduate students, and I was like, no way. Let's put that to a new line. Let's go here, and we're going to make it look even better. And then we go here, and we go to CEX, and we go to PCH, and the CEX is the point expansion. So let's go to 4, and let's go to 1, and then let's go to 18, and let's go to 5. Let's reduce the size of this right here. Here, we'll take a look. Hey, Brian, it's, oh, what's up, Error? Oh, cool, man. That's awesome. Great job, Error. Look at this. We're about to make some new plots right here. Here's our new plots. Check it out. Whoa. I think we made the point expansion on that too big, and I don't like those point styles. These are our point styles right here. We'll try a point style of 6. And now we get the, I don't like that. We'll go to the point expansion, bring that down a bit, because we got some crazy size on the point expansion. So now we get the following plots right here. Looking better. Let's change it to a 12. That's awesome, Era. I like it. Good to see. I'm gonna call you Era. That is. I like the Era name. See, we're not getting cool point styles. What I'm changing right here is the point style, and so it does different things. And I don't know. Maybe we just go with the old. Oh, we'll go with the circle. So yeah, it's pretty neat. This right here, we'll show this code looking a little better right here. We're using an if-else function on this code right here. So that way it's making a scatterplot matrix where we have the color selected, where if it's this certain point that we want to highlight, so we're looking through the row names. If the row names is equal to this, it'll be red. If not, it'll be black. This is character expansion, that's point style. So we'll take a look at the plot here in full, and we can see, hopefully it looks pretty decent, it's pretty easy to see where this point is at in every plot now. The whole point of what we want to do is we want to trace this point, 0.337, through every one of these plots. This is how we investigate data. So you can say like, okay, this point is very odd in its average temp, effective average temp. And Brad, let me drop that in the chat for you right here. So this whole code right here, Brad and Dennis in the chat, did that? I think the whole thing just fit. You can fiddle with the parameters on it if you see the way I have it, but this is the idea of what we like to try to code is try to figure out a way to do something like this, and then we'll do the next question here, Brad. But if you notice, it's also pretty odd in its, you would not notice that its effective average temp along with its demand is pretty far off. Do you see how it's kind of odd in this one, which is the same here? It's a mirror image. If you notice the symmetry of the matrix, like these are the two right here that are the same, and this one right here and this one right here are the same. So where's it most unusual? It's also a little off in that, but it's most unusual in its average temp, effective average temp combination, which gives it high leverage. That's where the high leverage is coming from because it's very unusual in its combination of X's. So that goes back to today's lecture. We got my Apple mug today. How we doing on that, Brad and Dennis? Did you get the code right there? We've got just really nice look at a scatter plot matrix right here. Much easier way to view it. And we'll hop down here to 2B. Is it 2A? I think Brad wanted 2A2. Great job, Dennis. And this is what we try to do with code is we try to, you're not required to do these things. You're not required to make a nicer looking scatter plot matrix. But hey, if we can do it, why not do it? And then this has us practice our conditional because this vector right here of values that it takes for the PCH, which stands for the point style, and you can just, once again, try out by changing, I think it takes numbers like 1 through 23. You can put in, I can't remember all the ones. I think you can literally put in like, you can put in like a B for Brian. Ooh, I think this one, yeah, there we go. There you go. There's a B for Brian right there. So you can do stuff like that. Could you put in a star? Star gonna work? It's a good start. Might work. Yep, there we go. Hey, that was probably the best idea right there we had. So yeah, there's the point we're talking about. Pretty easy to tell what points people are talking about through this, and you can control the point size and all this, but now it's pretty easy to see and identify what we're talking about. That's what we like to do, and we just changed it to that right there because we can use a character if we want. The influential point represents a data error, so we are justified in removing it. So you can remove things if they're data errors. Don't just remove things for the fun of it. Refit the model without this point and examine the results. So I think you're fitting a full model here. And so let's do this right here. We've got our new model. And if you notice, here is minus 337. So I'm going to make the original model, and I think there we go. So here we'll go to old model, m.old, and the old model doesn't need this. So there's the old model, there's the new model, and I'm going to see if I can do something right here. Whoops. There's the summary. Cool. Whoops, we don't want that. That was a comment previously. And here's the summary of the new model, but let's get a summary of the old model. And I think there's a way to get, so here's our two summaries. We have in the original model, we have an R squared of 40%, and then in the new model, we have an R squared of 42. Pretty awesome. In the old model, we have an R squared adjusted of 39. R squared adjusted goes up to 41. Good. We have a typical miss of 1339 in the new model, and a typical miss that's larger. So here's how the model is better. The typical miss did what? The typical miss went what? The typical miss went what in the new model? Here's the old model. This is old model value. This is new model value. Typical miss went where? The typical miss went where for the new model? It went down, which is good. The typical miss went down. That's what we want. We want that this model makes smaller errors. The R squared adjusted, which is adjusted for how many variables in the model, went what? The R squared adjusted, which we can actually compare. We can grab that from this. Which can we do? R squared? No. See, you have to store it into an object, which I don't get why you can't just. And then what is it? $. There it is. And so if we connect this on this. Really? Oh, I have to do $. There we go. So you can look at them this way. So I was browsing our studio websites and came across something called Shiny Apps. Yes. Yes. Error. Yes. Error. What you're talking about there is perfect. Yes, we are going to, yeah, and the R squared, is that adjusted R squared went up. Yep. In the new model. And error, you are 100% right. Shiny Apps are where it's at. I was actually building some Plotly plots, which basically are kind of like Shiny. You can put Plotly and Shiny together. So you can see one of the new videos. I haven't been making many of these videos lately because I've been busy summer. But Plotly and Shiny is really good. And keep learning how to code error. Keep doing it. Everyone in here will tell you If you learn how to code, especially while you're going through school, you'll have a lot of skill sets and a lot of opportunities. And I think you're already seeing that era, so keep it up. Yeah, learn Python, learn SQL, learn R. So that's my suggestions: is Python, SQL, and R. Learn those right there. There's a bunch of other ones. I mean, any coding language, C++, C Sharp, HTML, XML, the JavaScript. I mean, the more you learn, the better you're off. Especially, I have 2 SQL databases for. There you go. You're already doing it. That's awesome, man. That is awesome. Like they'll tell you, like you're doing a great job right there. So keep it up. It makes more sense. If you notice what I have right here is I'm just going inside this object. This object right here, the summary, I can store it, and I stored it into M. And if you notice right here, it shows me what's inside of here. There's attributes and everything to it. But rather than, going, yeah, no, that's what's awesome, Era. Congratulations on that. Keep practicing, keep learning how to code. If you have R questions, yeah, dude, keep doing it. Keep doing it. Stay focused and be like, I'm going to go to college. I'm going to come in with experience. And then that's what matters. Because everyone I've talked to said, I wished I had learned how to code earlier. I wish I had practiced. A lot of my students, and I'm so proud of them, come in with no, really? No. I saw the thing. That'd be cool. I mean, hey, whatever, I mean, especially at the rate you're going, try to get some scholarships. They say just apply to as many scholarships as you can. So keep applying to scholarships and choose the career field you want. Look into all career fields. I have my favorite. My favorite is business analytics, but you might go, I don't want to even say what you might go, but choose the career field you like. Whatever career field you like. I know Andrew's pointing out UTK is a great choice right there. And Andrew, do you wish you had started coding in high school? Let's see. Where's my students in the chat right now? If you're in the chat, do you wish you had started coding in high school? Eris joined us from some, they joined us for some Kahoots, joined in, gave some coding knowledge. And so, yeah, Andrew's like, definitely. If you had started coding 7th grade, that is awesome. I know a lot of schools. I did start. It was HTML. I know, right, Brad? Brad and I know what's up with that. Brad and I had a typing class in high school. I had a typing class. You might have had that also. So we got this one offered an intour. What my high school offered an intour course, and it was great. What is that? Visual Basic? Oh, that is awesome. That is great. Yeah, when you had to do like doing some HTML, typing class in middle school, Visual Basic and all that good stuff. That's what it's all about. The intro course. It was great. Yeah. I thought it was like a coding language. My high school offered a ton of college computer science courses. Yeah. That's awesome, Dennis. And Dennis is helping out with like our Discord and everything and all that good stuff. So we're starting to get that all, and we're just trying to grow what we do, and we want to make, well, but it's only for UT students, Error. I'm so sorry. No, I'm sorry, Error. It's only for UT students, and that's a big thing. No. So, Error, like, you got it, man. You got it. Or I don't know if your gender, but exactly. So it's only for UT students. So, yeah. And that's a big thing, and it's like the unofficial Discord, but it's for UT students. So, yeah. And so we're here to support you on the YouTubes, though, to give you some advice and to encourage you to keep coding, to give you like, you got this, keep coding, keep doing what you're doing. You got it right there. So awesome. Any other questions about the homeworks or stuff? Had a good office hours. You're welcome, Error. No, we are. I like that. Just call you Error right here. So do you like being called Error? I know you're like anxiety today. So, but I always call you Error. It's like in Zelda, you should curse. Well, join up to UTK but please go to the college you want. That's my advice. Or do what you want in life. And then we got a question here, 474. NXI. There you go. See you, Andrew. We got 474 question. We'll hop back to 474 right here. Quick question for number 7. Does S represent the lambda in 474? Let me see that one real quick. More coding. Look at this error. I don't know if you're here for this, but we coded this. Oh man, it's not too crazy. It's a nested for loop which populated our results for our matrix, and we ran 400 different models and created the results to figure out which model was the best. But we have a question here on number 7, Jordan, 100 lines. Well, I do have some code with like 100 plus lines. I think it's this one right here. This right here has a couple. There you go. There's over 1,000 lines right here. So this right here is there we go, 2,300 lines. I know. So yeah, no, we got a few of those. Here we go. We'll hop back. No, it's more you practice. More you practice. So is it the piecewise one, Jordan? Oh, okay, cool. I think it's this one. You're gonna come back and be like, it's 14,000 lines. Piecewise linear regression is a technique that assumes a nonlinear relationship between y and x can be modeled with the right series of linear pieces. Take, for example, the following relationship. Okay, cool. I think it's going to show a plot right here. What you need to understand about piecewise is what we're going to do is we're going to take data like the following. And how many pieces do you think would be the right amount of pieces for this right here? Holy moly. Great job, Error. Great job, Error. How many pieces do you think would be the right amount to model this? How many pieces do you think would be a good amount to model this, Jordan? How many pieces would be a good amount to model that? 3. Yeah, I totally agree. You would go piece 1, piece 2, piece 3. So it could be 5. So, and this is what this question is going to be getting at here. So you could fit 5 pieces to it. So you could fit 5 pieces like that. Could I fit 100 pieces to it? Could I theoretically fit 100 different pieces to it? Could I fit 100 different pieces to this model? Could I theoretically? Yep. What's the smallest amount of pieces I could fit to the model? Could I fit just 1 piece anime to the model? Could I fit 1 piece to it? Could I? Well, I can. I mean, it might not be the best idea, but I could. I can fit 1. I can fit 2. I can fit 3. I can fit 4. I can fit 5. I could, you're right. And then the question we get into is what's the right amount of pieces to fit to this? So does that make sense that like the question becomes what's the right amount? And 2 might be the best. 2 might be the best, like maybe 2, which might fit like this. 2 would probably fit like that and like this. So the question might become, what is the right amount of pieces to fit? I tried to draw it so that there would be 3 pieces. I kind of thought it had this sort of relationship. But then maybe it does, maybe it doesn't. So let's look at the question right here, which I think is showing the same sort of thing when it comes to the pieces. So let's make this a little bit bigger so we can see what's going on with the graphics. We're going to go right here. And we've got the segmented. Oh, look at this. Here we go. There we go. So we got the same sort of idea going on right here. And we've got 2 pieces and 3 pieces. And we might be able to fit even more pieces. We could do something like that. So we could go back to here and line width, all this right here. Underfit, just right. So legend, does it plot y tilde dot. Is it already fit in here, the underfit model? Oh, because I think we already fit this in the data set we already did it. Okay, so when you look at this right here, the question becomes how many models we need to fit. I mean, how many segments do we need to fit to this data? If you notice, this goes through here, then you got your other segment, and you got your other segment here. This right here only has 2 pieces, so 3, yeah, I agree. Great job, Error. Error 100 points, because you remember you got those Streamlab points. What's your anxiety today? So your points are going to be totally different. So overall, but it might follow the name. I don't know. Probably changed it. So the overall relationship between y and x is not linear between right here. So you see you've got between 1 and 5, it's linear. And then between 5 and 15, it's right here. And then between 15 and 20, it's also linear. The number of linear pieces is our tuning parameter. So we're going to figure out the right amount of linear pieces to do. Let's refer to the number of pieces as S for short segments. Discuss how the tuning parameter S changes the bias variance trade-off. So discuss which choice of S, small or large, makes the model and its predictions more sensitive to the particular set of individuals. Now, does that sound like bias or variance, Jordan, when it's more sensitive to the data we're using, i.e., taking more info? Does that sound like high bias or high variance when it's more sensitive to the data, like we're taking more info? What does that sound like? High bias or high variance when it's more sensitive to the data? Ah, it's going to be the other one. We'll see. It's going to be variance. And the cool way to think about this error is imagine, I'm trying to think of the best way to explain it. Let me try drawing some pictures here too with this. Imagine you collect data from your friends. So here's the best way. We'll talk about pizza because everyone loves pizza. So you go and you want to make the perfect pizza for your friends. Now, if you talk to your friends, what would be the way to make perfect pizza for those 5 friends you talk to? You talk to your 5 friends. We're getting some A+ drawings right here. We're going 2 friends. You talk to these 2 friends right here, and you want to make a perfect pizza for them. So how much for them? How much info would you want on their perfect pizza? Like how much data would you collect? How much data would you collect from them to make a perfect pizza for them? If you want to make a perfect pizza for them, the most possible, exactly. So in this, we're taking tons of data, like tons of X's, like tons info. And then because we have tons of info, do you think they're really going to like this pizza? For them, these 2 friends, do you think they'll like their pizza? Based on them, do you think they'll like their pizza? Those friends right there, do you think they'll like the pizza that we made for them? We made this like specified right to them. So now we've taken tons of information, right? So this pizza has very low what for these friends' taste. Has very, be careful. It does very well at what the friends want. Yes, Jordan, you're seeing it. You're seeing it exactly. As we increase the ingredients based on what they say we should do to it, it's going to become more dependent on those friends, and we're increasing the what. I've changed the previous answer, but we're increasing the what, Jordan, by taking more info from these friends. By taking more info from these friends, and I really like this as a test question, by taking more info from these friends, and we're basing it more on them, we're increasing the what because of that. The variance, exactly. Because when you think about this, if you had 2 totally different friends, and if you take tons of info, do you think these 2 totally different friends are going to love this pizza up here? Do you think these 2 totally different friends are going to be like, that's the best pizza ever? It's 2 totally different friends, which were not what the model was created from. Do you think they're like, that's the best pizza ever? What would you think? Do you think they're going to love it? They're going to be like, that's exactly what we want. Let's see here. So let's put here high variance. And for these original friends, has low bias. Yeah. So you were Jordan. I like that error. So for the friends we created the pizza for, the low bias means that the low bias right here for the friends we created it for, they love it. But what could we do? So think about this right here. What could we do to make a high bias model with low variance, like a model that does not do as well? We could instead do what? Instead, not take tons of information. We could take a little amount of the X's, which means a little amount of info. Like we say, just cheese. We could just say, like, what's your favorite topping for pizzas and how much sauce do you like? We could only do a little bit of info, like, what do you think we should do for the cheese and what do you think we should do for the sauce? Like, we don't say, like, and what bake temperature. So we do, like, we take less information. So now the model becomes higher bias, because do you think these friends will love the pizza and say it's the best pizza ever? They might think it's okay. Like they'll be like, that's a decent pizza. But when we feed this pizza to our new friends, the low variance means they're going to have about the same opinion on it. So the high bias means that we don't make the perfect pizza for the original friends, but when we give it to the new friends, they like it about the same. Like it's like it doesn't have variance between different groups of people. Does that make sense right here? That if you take a little bit of info, you will not do as well. If you take a little bit of info, you do not do nearly as well. Your model's going to make worse pizzas. But when you take a little bit of info, if you give the model to new data, which is the new people down here, the model will do about the same. It'll have lower variance. Error. I couldn't agree with you more. Olives are horrible. Olives are about the one thing I don't want on pizzas. You put mushrooms, you put onions, mushrooms, onions, pepper, and ham. That sounds like a really good pizza to me right now. Maybe like a pesto drizzle on top. I don't know. Now it's getting crazy. It's too much. It's too much. I don't know. Pineapples are good. Pineapples and ham is really good. You got to go pineapple, ham, thin crust, though. There's an interaction between pineapples and ham and thin crust. So, like, that's like the trifecta interaction right there. Really good stuff. I'm so sorry, Dennis. You know what we need to do? I don't know. Stupid COVID. I want to give away a pizza via, like, one of our Kahoots. I want to be like, you just won a pizza, and like call in the pizza for somebody, but we would need like their I have no idea. So I think that pop probably gives away right here. If you're increasing the number of segments, what are you doing to the data? If you're increasing the number of segments, what are you doing right here? Discuss which choice of S, large or small, would make it more sensitive. So what would make it more sensitive, Jordan? Large or small S? What would make it more sensitive to the data, which means higher variance? A large or smaller S? What would make it more sensitive? A large or small S? What would it make it more large? And that means higher variance, because it's going to try to like overfit to it. The larger the S is, the more segments, and it's going to like bend through the data. Discuss whether increasing X makes the variance of the model increase or decrease. It would make it increase because you're making it more sensitive to the data it's created from. These two are basically the same question. Don't know where I wrote it twice. Discuss whether increasing S makes the bias of the model increase or decrease. If you increase S, what's going to happen to the bias? This is when you fit the data even stronger. So if you increase S, what would happen to the bias of the model? If you increase S, the bias of the model must do what? The bias of the model must do what? You know what we should do? We should make some pizzas. We'll make pizzas to end class. We're going to make pizzas to review. So if you increase S, the bias will go down. Yep, because it's going to put more lines. And if you put more lines, it'll fit tighter. You can see it in this example here. Because there's more segments here, it gets slower as time goes on. If Dennis is still here, like it starts out fine. Maybe I just need to reset the computer. And so here, you'll get your pizza 2 anxiety. You'll get it. You'll get the pizza. You want to make pizza in class? Yep, we're going to make pizza here. I mean, it's online pizza, but still. Discuss how we choose the right value of the S should be chosen. We need to make 2 things, and then how do we pick the right one? So one thing we need to make, here's the 2 things. We need to make a tuning grid, and this is, don't put this on your homework assignment. We're going to call here pizzas, and here's the pizzas. We're going to go expand grid, and we need crust. So crust for the pizza, and I think this should work. Crust is equal to either thin, regular, deep dish, or New York. And then what else do we need? We need toppings. We need topping 1. Topping 1. Put some toppings in the chat. I need some toppings. I need toppings in the chat. And then we need topping 2. And I need toppings in the chat. We need sauce. I go here, regular. I'll look in the chat here in a second for the toppings. Regular and light and extra. We spell it that way because then everyone thinks we're cool if we don't put the E on the extra. And we need here cheese. And let's go here to, here, we'll just copy this. Well, no. We need to put cheddar or sharp cheddar or blend. We got like a blend, Italian blend. Chicken, bacon. Make sure you don't have background processors running in the background, taking up unnecessary. Yeah, I need to look into this, Dennis. Might have on like the Discord with you. Steak. We got anxiety. Anxiety, you're gonna get the first pizza right here. We got only meat options. No, we could do. Watch this, anxiety. We're gonna go right here and we're gonna go toppings, and we're gonna take your toppings and we're gonna store it in a vector outside of this, so we don't have to write it all out twice. And we're gonna write here chicken, bacon, steak. I'm putting some mushrooms. So these are 2 topping dominoes. Onions. Anyone got any other preferences? Because we're about to run out. We need to know when we're topping right here. Looks like steak is the preference. And we'll put filet. Okay, here we go. Okay, I just made your... Whoa, wait, what? What did I do? What did I break? Error. Unable to find method expand. Oh, expand grid. Cool. Okay, we made the pizzas. Expand grid. So there. You lost me with filet. We put filet mignon on our pizzas. That's what we do. We can make a... We gotta make a lobster. We gotta put lobster on here too. So, so we got filet and lobster possible. Someone could get a filet and lobster pizza. And we have to go here to... sorry. I'm just so hungry for pizza. Sauce type. Let's go here to garlic sauce. We got a garlic. We got tomato base. And we've got here, like, what is it called? What is it? In Florida, we put gator. You know what? We offer that too. We got that right here. We got gator. And then, what is the other one? Oh, pesto. Let's do pesto. Okay. Oh, man, we're going to get some crazy pizzas here. Tomato. Yeah, that looks like how you spell it. And then we're missing a comma right here. Thank you, R. Very nice of you to tell me where I'm missing my commas. Okay, we just made 6,912 pizzas. You recommend Stefano's? You bet. Stefano's is good. Chicago pizza. Which, you know what? We didn't put Chicago on here, so we could put. We got Stefano style Chicago pizzas. This is going to drastically increase the expand grid. Okay, now we've got 8,000 pizzas. We have 8,000 pizzas. What pizza does someone want? You only get one pizza. What pizza do you want? What pizza do you want? What pizza do you want? Article for a dead... Oh, Brad, you got 100 points killing me here, man. Oof. I had those like coded into my soundboard at one time. I had some interesting sound effects. You got to name the pizza number you want. What number is your pizza? Anybody got? Oh, it's fine. Oh no. What pizza number? 5850. You are getting, wait, it's pizzas. You are getting a Chicago bacon and steak pizza with garlic sauce and a cheese. Jordan, that's an awesome pizza. That's an awesome pizza. You get a regular lobster and gator, cheddar, garlic. That is interesting. Anxiety, you got that. So, call your air right here. Let's make one. I'll make my own pizza. I gotta make a pizza. I'm going for pizza 5531. Pizza. I get thin crust, double steak, extra sauce, pesto. I'm happy with this pizza. So this goes back to the question, like, why do we do this craziness? When we build models, we can test thousands of models. So what the computer can do for us, if this was like, if we were having the computer analyze this, it could analyze what the best pizza is. And that's what we're doing with models, is we put in our tuning parameters. So this goes to the previous question. We are going to make a tuning grid, and then we're going to find the model that works best on the what portion of the data to select our model. Jordan, what our model is going to be selected based on the what portion of the data. Like what data selects our model. We make a tuning grid, and we pick the one that works best on the what portion of the data. Be very careful. Because you have what makes your model, you have where you're testing your model, and awesome. We'll be done here in a moment, Era. So, bye. Oh, and I got something cool here to end class, Era. So, that's the final test, Jordan, and that's the mistake people make. We don't select our model based on the holdout. We see how it works, and we know if it works based on the holdout. We select our model based on the validation. I'll end there in like 1 minute, but we select our model based on the validation. So how are we going to pick our model? We'll make a tuning grid of all the different S's, and then we'll pick the one that works the best on the validation. Does that make sense, Jordan? How do you know which one to pick? What is the right choice of S? You'll make a tuning grid of all your S's, and then you'll find the one that works best on the validation. And then you test it on the holdout. So we choose our model based on the validation. You know if it works based on the holdout. We don't choose it on the holdout, because if we choose on the holdout, last word for the day, we might what on the holdout. If we choose it based on the holdout, we might what the model to the holdout, which is not what we want to do. If we choose it based on the holdout, we probably might be doing this. Like there's a bad chance we might do this. If we choose it based on the holdout, 100 points to end class right there on your right. If we choose it based on the holdout, we might just be overfitting to the holdout, which means it might not generalize to new data. So we don't choose it based on the holdout. We literally pick it based on the validation, and then we see if it works. Overeat because there's 600 pizzas. One last pizza to end the day. And then I'm going to see, I think Jason's telling me I got to end class, my classic. We got a deep dish chicken and gator pizza. Hey, Jason, do you want that? Jason, can we go for a little bit longer? Jason, are you cool with that, man, Jason? 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.